Syllabus Mathematics Book 2 Updated 7th edition, Chapter number 1, Primes, Highest Common Factors and Lowest Common Multiples. Exercise 1A, Intermediate Level Question. Question number 9, check whether 90 is a perfect square or not. There are several methods to check whether 90 is a perfect square or not, but I will use the prime factorization method. First, I will divide 90 by 2, which gives us 45. Then I will divide 45 by 3, resulting in 15. Dividing 15 by 3 gives us 5. And multiplying 5 by 1 gives us 5. We have prime factorized the number 90. As you can see, only 3 can be grouped into a pair, while 2 and 5 are left without a pair. You have also studied that if the prime factors can be arranged into pairs, then the number is a perfect square. Thus, 90 is not a perfect square number because it cannot be expressed as the square of an integer. Another method to check whether 90 is a perfect square or not is by taking the square root of 90. The square root of 90 is approximately 9.4868. which is not a whole number. If the square root of a number is a whole number, then the original number is a perfect square. For example, the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. In this example, 4, 9, and 16 are perfect square numbers because their square roots 2, 3, and 4 are integers. So we say that 90 is not a perfect square number because 90 can't be expressed as an integer squared. Alright, moving on to number 10, we have the length of one side of a square sheet is 15 centimeter. Find the area of the sheet. It's a general-based question. Since a square has all four sides equal in length, the length of each side of the given square sheet is 15 centimeter. The area of square can be calculated by multiplying any two sides of the square. That is, length multiplied by length or square of the length. So our first step is area of the square. A is equal to square of the length L square. In the second step, I will substitute the length as 15 centimeter into the formula. The square of 15 is 15 times 15, which gives us 225 square centimeter, which is the required area of the square sheet. The statement of question 11 is as follows. Determine which of the following is a perfect square. To determine whether the given numbers are perfect square or not, let's find their square roots. If the square root of the number is an integer, the number will be a perfect square. If the square root of the number is not an integer, the number will not be a perfect square. First part from this question is 2809. The square root of 2809 is equal to 53, which is an integer. Therefore, 2809 is a perfect square number. The second number is 1155. The square root of 1155 rounded to 3 decimal places is approximately 33.985, which is not an integer. Therefore, 1155 is not a perfect square number. Moving on to number 3, we have 2021. The square root of 2021 rounded to 3 decimal places is 44.956, which is not an integer. Therefore, 2021 is not a perfect square number. Moving on to number 4, we have 1681, and the square root of 1681 is 41, which is an integer. Therefore, 1681 is a perfect square number. And now advanced level questions. The statement of question 12 is as follows. If P and Q are whole numbers, such that p times q is equal to 37. Now keep in mind 37 is a prime number. Find the value of p plus q. Explain your answer. Now it is stated that p and q are whole numbers and 37 is a prime number. Therefore, the possible factors of 37 are 1 and 37. Then their product p times q is equal to 37 times 1 is equal to 37, which satisfies the given condition. Now for p plus q, adding these two prime factors gives us 37 plus 1 is equal to 38. Hence the value of p plus q is 38. One point I want to clarify is that we can only take the values of p and q as 37 and 1 or 1 and 37 because 37 is a prime number having only two factors, 1 and 37 itself. Moving on to question 13, we have if n is a whole number such that n times n plus 42 is a prime number, find the prime number, explain your answer. It is mentioned in the question that n is a whole number. And what should be the value of n that satisfies the condition n times n plus 42 is a prime number? We know that whole numbers start from 0. If I take n is equal to 0, the statement becomes 0 times 0 plus 42 is equal to 0, which does not satisfy the condition n times n plus 42 is a prime number. If I take n is equal to 1, the statement becomes 1 times 1 plus 42 is equal to 43, which is a prime number. I have checked the values of n for 2, 3, 4, 5, 6, 7 and so on. Only one can satisfy the given condition. Here is the clarification process. If we substitute n is equal to 0, we get 0. If we substitute n is equal to 2, we get 88, a composite number, not prime. If we substitute n is equal to 3, we get 135, a composite number, not prime. If we substitute n is equal to 4, we get 184, a composite number, not prime. If we substitute n is equal to 5, we get 235, a composite number, not prime. And if we substitute n is equal to 6, we get 288, another composite number. And if we substitute n is equal to 7, we get 343, a composite number, not prime. Therefore, the only number that satisfies the condition is 1, where n times n plus 42 is a prime number. And our final answer is 43, a prime number.